it's me. I was wondering if after all these years you'd like to meet.
Hello, future Taejung. Welcome back. After that really emotional intro, oh man, I need another box of tissues after that one. Anyways, we're doing Quideo number 5 on chapters 12 through 14. Let's do it. Here we go with the basic problem. The drug AZT was the first drug that seemed effective in delaying the onset of AIDS. Evidence for AZT's effectiveness came from a large, randomized comparative experiment. The subjects were 1,300 volunteers who were infected with HIV, the virus that causes AIDS, but did not yet have AIDS. The study assigned 435 of the subjects at random to take 500 milligrams of AZT each day, and another 435 to take a placebo. The others were assigned to a third treatment, a higher dose of AZT. We will compare only 2 groups. At the end of the study, 38 placebo subjects and 17 of the AZT subjects had developed AIDS. We want to test a claim that taking AZT lowers the proportion of infected people who will develop AIDS in a given period of time. Alright, let's start out with A. State the hypotheses and check that you can safely use the Z procedure. Alright, so you got your 2 hypotheses, the ho and the ha. Null, alternative. The ho is that the proportion of the infected people who developed AIDS after taking the placebo is equal to the proportion of the infected people who develop AIDS after taking the AZT, or the P equals PAZT. The ha is that the proportion of the infected people who developed AIDS after taking the placebo is greater than the proportion of the infected people who took AZT. PP greater than PAZT. So how do you know that that's greater than? Well, it's because we are given a direction. We want to test the claim that taking AZT lowers the proportion. Therefore, if it lowers it, it will be less. So those are the 2 hypotheses. Now, check. All right, so this is the assumption if you're doing a phantom or a pants. The problem states randomness right here, large, randomized comparative experiment. And just in case I get this wrong, they're independent. Better safe than sorry. Rule of thumb number 1 would be that this 1,300, which was the subjects, the number of people they interviewed treated. If you multiply that by 10, it would be less than or equal to the total number of infected people in the U.S. In other words, you can repeat this 10 times. There's plenty of people with HIVs. And rule of thumb number 2 is that the NP is greater than or equal to 10. You got the N, sample size, and the P, proportion. 38 out of 435, 17 out of 435. And then you got that Q. And they all work out because they cancel out. We're good. Let's proceed. B, how significant is the evidence that AZT is effective? To test the significance, we need to do some sort of test, right? To, reject the whole or fail to reject it. So we would use a 2 proportion Z test for this one because the problem says that we're only comparing 2 groups and we're given 2 proportions, the 38 out of 435 and 17 out of 435. And I would need to plug that into this monster of an equation. I'm not going to do it. I don't, live under a rock. I don't live in a cave. We're going to use this thing. This lovely machine of numbers. Okay, so first you go to stat, test, 2 proportion Z test. And everything's plugged in for you. You got that 38, 435, 17, 435, your 2 proportions. And you would have to do this because the ha, if you remember, was that the proportion of placebo is greater than the AZT. So you'd have to do greater than P2 and calculate that ish. And you'd get this, 2.93, 0.0017. Cool. So then the conclusion is that we would reject the ho, that the proportion of the people who developed AIDS after taking the placebo is equal to the proportion of those who develop AIDS after taking the AZT, based on our p-value of 0.0017, being less than our alpha value of 0.01. In other words, the AZT works. And lastly, C. The experiment was double-blind. Explain what that means. Oh, it just means that both the patients and the doctors, they couldn't see. Just kidding. That wasn't funny. Anyways, double-blind means that the doctors did not know which treatment they were giving the patients, and the patients did not know which treatments they were receiving. The treatments are the placebo and the ACT. This eliminates response bias and puts a smile on my face.